Have you ever wanted to know about E85? Well, stay tuned. We're going to be throwing E85 in the 2-rotor. I'm going to show you how to set up a flex fuel system so that you can run pump gas or E85 in the car. We're going to show you how to road tune that setup and show you how it all works. This is going to be a fun one. Stay tuned. Okay guys, so what is a flex fuel setup? A flex fuel setup's really awesome because a flex sensor, basically what its job is it measures the amount of ethanol that is inside the fuel coming from the return line, usually of your route. In this car, I've actually got it from the return line into the surge tank over in the corner there. So the fuel comes out from the tank into the surge tank, then circulates back through the flex sensor and then back into the tank. Now, when doing the setup like this, just a little word of warning. The further you have your flex sensor away from the fuel, you're going to have that delay between when the fuel is pumped into your slosh tank or surge tank and then back circulating back into the tank. Now, the reason why this is relevant is because the flex sensor's job is to tell the ECU how much ethanol is in the fuel. Now, this is really cool because what we can do is we can adjust the tune based on how much ethanol is in the fuel. And this allows us to run any type of fuel we want, whether we want to have E85 or pump gas. The tune will just adjust depending on how much ethanol is in the fuel. The main thing is with your flex sensor, if you have it in a setup like I have mine, just be aware that time it takes to circulate through might take 3 or 4 minutes before the flex sensor picks up the new fuel that you're putting in. So it's always best in a setup like this, don't gas up the car with E85 or I should say pump gas while it's had E85 in it, and then go put your foot down because you might be getting pump gas in while it's running the E85 tune and you could do some damage. So when you do change your fuel in a setup where your flex sensor is far away from getting the current fuel that's in it, you've just got to be aware of that issue. Now, in order to combat that issue with my setup, I've put a really high flow pump in the tank. So this small tank circulates very quickly. So we shouldn't have any dramas like that. But if you do put a new tank in, you just want to drive it around for 5 or 10 minutes and let that fuel circulate so you get a precise reading from the flex sensor. So that's how the hardware side of it works. I'll show you some pictures of the flex sensors and what they look like. So let's dive into the Haltech software and show how to set up the maps, and we'll go through all of that. After we finish that, we'll jump in the car and we'll start road tuning it. Now, I have not driven this car since the last time I've changed these maps. I had that many dramas setting this all up, and one of the things here on this channel, I believe that information should be free, and that's one of the things I want to give to everyone who's watching. Anything I learn from tuning, anything I learn along the way, I'm going to be passing on to you guys. Another thing too, I've got a website that's coming up on soon. It's the Mechanical Warriors website. It's where we're going to be selling the tickets for the cars that we're giving away. It's also going to have courses on there for anything to do with cars. These are all going to be free. They're going to be really detailed courses, how to tune, how to road tune, how to set up flex setups, the whole works. Anything you want to know about a car is going to be on there, and it is going to be 100% free. So please like and support the channel if you like that sort of stuff. So let's get stuck into the software side of things. And then after that, we'll jump in the car and we'll start tuning this baby up. All right, so here we are. We're on the NSP software connected to the car. Now, just before we start, before I've done this video, I actually had quite a lot of mucking around with figuring out the best way to set up these or the flex fuel system. I want to show you two ways that you can do it. The first way is that you can add, for example, let's go into this table axis, and you can see a third axis which we can enable for fuel composition. Now, we'll get stuck into that in a second, but first I just want to show you in your sensors area, you will have a flex fuel composition sensor. Now, after you've installed the flex fuel sensor in the car and it's working correctly, you enable the sensor, wire it up, and then you have to do a little bit of tuning, which this sensor should come with its hertz rating, and you basically just change these values so that it's reading correctly. It's kind of a calibration method. Well, it is a calibration. So after you've calibrated the sensor's working fine. Great. We now have a flex fuel sensor on the ECU. So we have a fuel composition reading, which at the moment we are reading 45% ethanol. So what can we do with this? Well, if we go into our table axis setup, now this is not the way I'm recommending to do it. However, this is a way you can do it. And this was the way I was doing it in the beginning. So we can say flex fuel composition, then we can enter values like 0%, 10%, 20%, 30%, 40%, 50%, 60%. Let's get, we normally would not have 10% in there. So we go 70% and then 85% because E85 is 85% ethanol. So that's your highest quality fuel there. Now, when we enable that, you can see that we have a fuel composition bar down the bottom here with an arrow pointing to where we are. Now, each one of these sections is a map of its own. So if I go to the 85% margin, and let's say I change that to 10, if we go back here, it's back at 4. All right. Now, this is obviously one way you can do it. However, you do have to go through and individually tune all of these maps as well. This is on the ignition timing, but you would do the exact same thing on your base fuel map, and you'd go through and tune the fuel as you changing your composition. But this is a terribly laborious job, and we're not going to do that. So, what's another way we can do it? Inside with the NSP software, we have fuel compensation correction and fuel compensation scaler. Now, how does this work? The fuel composition scaler shows where the percentage of ethanol is. So we're about 45%. Now at 45%, we have an output of 65% of this map. All right, so our we're in ignition table. So on the ignition side of things, we can safely run around about 4 degrees of timing when we're at 85% ethanol. Okay, now, but if we're not at 85% ethanol, then we have to obviously reduce that timing dependent on how much ethanol is in the fuel, because otherwise we'll cause detonation. So how we do that is by here. So this is saying we're at 65% of our 4 degrees timing. All right. So if we were at 50%, right? If I was to put 50% in here, then we would be using 2 degrees of timing. All right. If we were at 100%, then we're using 4 degrees of timing. So this is basically a scaling percentage map of your total amount that you put in here. Okay, now I've put 4 degrees across the board, and that's what I'm going to roll with. So very, very, very simple way to set it up, and way easier than the other way. Then you basically keep your current map, and you get this correct as per what you want to run on pump gas, and then you just add E85. Now, any corrections that you would make in the timing, you would do it on this map in your boost. So if let's just say you wanted to run slightly less timing at 30 pound, then you would add it in here. You would take that timing out of here. You could also add the timing in here. It won't really matter, because basically this is just going to add 4 degrees onto anything you add in here if you're at the 85% ethanol rating. If you're 50%, then it's going to add 2 degrees on top of whatever number in here. So you could still use either side. It's totally up to you, but I'm going to keep this map based off my actually no, I'll tell you what, I'm going to use the map in this way. From 16 psi is the maximum amount of pressure that we're going to run on pump gas, and I'm going to program the boost control so that it will not go over 16 pound no matter what you do if the alcohol content is at 0, and then that boost will increase depending on how much ethanol is in the fuel. So that is how we set up our ignition table. Let's go to fuel. All right, so base fuel map. Now, this needs a lot of work up in this end of the map. However, up to around 14 psi, it's not too bad. It does need a little bit of work that we're going to play with that today. Now, the next thing is we go to corrections and we want to enable fuel comp correction or fuel composition correction. And we get these two options again, the same as what we had in the ignition timing. So fuel composition scaler. Now I've left this, well, I did modify it slightly so that we're matching the same scale as with the ignition timing, because we're never going to be running 100% ethanol. Some cars obviously do. If you're running a drag car setup, then you can just change the map and add whatever percentage you want to have, and then your value as per that percentage. So at the moment, we're at 85, well, we're here, but if we were at 85% ethanol in the fuel, we'd be at 100% of this chart. Now, this is basically giving us an extra duty cycle on top of what we're already doing on the base map. So then what I've done under different PSI and different RPMs, I've just added more load to these into the injectors for these different PSI ratings. So this is going to have to be tweaked slightly, but this is just the base setup. Like I said, I haven't even started this car yet since I've put this on. Now, so we are going to be at 40, well, 48, 44.8, well, between 44.8 and 57. So the output here at the top you can see is 50.9, because as it slides across these scales, it doesn't just jump from this number to this number. It slowly linearly climbs in between each number, and that happens across every single map throughout the entire ECU. So basically all we've got to do now is jump in the car and start driving it. Now there's another couple things that I want to talk to you guys about with tuning O2 correction control. My last road tuning episode where we used O2 correction control was great, and you can use it to road tune. However, in this episode, we're not going to be using the O2 correction control. In fact, we're not even going to be using our short-term correction control. So we're going to be turning all corrections off so that we're getting 100% straightforward data and nothing manipulating it. All right, so enough of that. Let's put some more E85 into this car so we can get our ethanol content up nice and high, and let's go for a drive. Okay guys, we're out and about. So I'm having a lot of problems with my GoPro camera actually, and it keeps deleting footage on me and causing all sorts of errors. I'm ready to burn the thing, to be honest. Anyway, moving on. So last night I had a bit of a play with this fuel composition correction and the fuel composition scaler. I found out some interesting things. When I had this map here, now if we go back over to our ignition timing, we see the same thing, fuel composition correction and then fuel composition scaler. So from what I've been told, this scaler scales whatever you put in here. So let's just say we're at 4 degrees, then this is at 95% of that 4 degrees. So you would assume that the fuel side would operate in the same manner, but it doesn't. And I'm not sure why, but I had like quite high numbers in here to begin with, around 35%, and the car was just running stupidly rich, almost to the point where it wouldn't go. So I kept dropping it back, checking the AFR settings, and the more I dropped it back, the more they came into what they should be. To the point where I got this to 0, and it just, everything came bang on. And we're going to do a pull here in a minute. I'm going to show you the my AFR versus the target Lambda, and it's perfect. And I haven't really done anything other than enable this fuel correction setting and add 4 degrees on this correction map across the board for any, well, when we've got ethanol percentage of 70%, we're at 95% of that 4 degrees, so adding 4 degrees, so it'd be like 3.8 degrees at that setting there, something like that. I don't know the math, but anyway, it's interesting that this ignition table works differently to the fuel. So I'm going to do a little bit more research into that, but so far the car is absolutely rocketing. And so what we're going to do is we're going to do another pull and record the data. I'm going to show you the data on here, and then we'll go for a little bit of a drive and do a couple of pulls. I'll show you the car pulling from the outside. So let's get stuck into it. Okay guys, so we've pulled over. Now let's check this data. We did a from first, second to third gear pull, and here's our data. So first gear is a bit all over the shop. It's expected because there was a lot of spinach there. Second gear is a bit more traction, so a bit more load. We get a bit more of a steady reading here, which doesn't look too bad. There's a little bit of up and down movement here, which I'm not sure why that's doing that, but we'll have a look into it. But it's fairly close, like 11.6, our target is 11.4, 11.5. We're very, very close. Gets a little bit rich there. This one here, I mean, that's bang on. Even during our methanol injection, we're not even really seeing a rich spot. Now I've still got O2 correction control switched off and also short-term correction control switched off. So there's no corrections happening to this map. It is solely running off the map. So this is real data. So yeah, obviously I do want to say too, if you are doing a tune like this, don't just jump in and go stupid like what I just did before, because obviously you want to slowly increase the RPMs and you want to really listen to the engine. Like if you have an exhaust valve, open it up so you can really hear the motor and listen to what it sounds. You can hear when the engine is running rich or when it's running lean, and learn to understand that, and you can pick up events happening and possibly save your engine. So I'll do another pull shortly just to show you how you would want to do a pull when you're checking data, but I've already checked this data yesterday, or last night I should say, and I was blown away by how bang on the AFR is, even after this fuel correction map is still at 0. So I'm going to have a chat with Haltech just to double confirm all this, and I'll update in the comments what they say to me. But so far this flex system is working perfectly. We're at 70% ethanol. The car is absolutely rocketing. We're only doing 14 psi, mind you, and we're losing traction in third gear. So I think we'd probably be around the 450 horsepower mark, maybe a little bit higher, maybe a little bit lower. But we're yet to push the car up into that 30-35 pound margin, which we'll do that on the dyno. I don't really feel comfortable, and I'm not going to push it that far until we've put the straight cut gears in, because I don't want to break the box just to try and get a horsepower reading. I'd rather change it first and then push the power harder. But so far it is absolutely awesome to drive. And yeah, so that's it basically. That's all you got to do to set up your flex system. Make sure that you continually check this data. Remember, data is king. The more data you're collecting and the more you're analyzing that data, the better off you're going to be. Don't just think you know, don't ever run the gauntlet, we say here in Australia, which means like take a gamble. Check the data, make sure everything's all right, don't guess. And yeah, let's do one more pull so I can show you how you would do that. Obviously you're not going to just go berserk like I did before. Yeah, we'll wrap this up. That'll be it for the video. Alright, so first let's drive the car for a bit because we've been pulled over there. Let's get that heat out of the engine, get everything nice and, I'm going to say, level with heat, as in the heat is even throughout the engine and also through the oil. And then we'll log another pull. Alright, so we're coming up to a spot. So data logger on. So we use third gear so we get a good amount of load on the engine. And then just slowly apply gas. That's all you want to do. Just a quick little splat like that. And then pull over and check your data. Alright, let's check that last one. So open the data logger. It's a 16-second log. Load our workspace. light so we can see everything. Alright, now where's our pull? Here it is. Okay, so if we look here, on this pull we're running a little bit rich throughout the whole thing. And basically that could have been just because the way I hit the gas. If you see, I sort of came on it slower and slower, then sort of came off. When you do put your foot down on the gas, all the way to the floor, all the way off. Okay, you don't want to up and down, because every time you move your throttle, you create a lean point. As soon as that valve opens and shuts, you're letting a lot of air in or restricting a lot of air relatively quickly, which creates lean spots that you can't completely get away. So you want to give it a little bit more, like make sure your foot's all the way down, and yeah, don't play with the throttle like I just did there. So that wasn't a very good example, but you get the idea. Small little hit. If your AFR is looking too good and the engine doesn't sound bad, go a little bit further, go a little bit more, stay in third gear, hit it a bit harder, pull over, check your data. If you need to make some changes, make the changes. And to make the changes, like here, like let's just say this was still a bit rich and I wanted to change it, I would just go to that area on the map and pull a little bit of fuel out. And that's all it is, just going through it bit by bit.